Hello, my dear friends. Today, I want to discuss geometry of single point cutting tool. I am Dr. Somnath Das, Assistant Professor of Science and Technology in the Department of Mechanical Engineering Department. So, this is the learning object that been within this video lecture. I covered actually introduction to features of single point cutting tool and concept of rake and clearance angle and its importance. Both material and geometry of the cutting tool play a very important role in their performance in achieving effectiveness, efficiency and overall economy of machining. If you have a blunt tool, you cannot cut a product rightly. Excessive amount force is required, excessive amount time is required. So, effective tool is very much required to produce something. Okay. Now, I want to clear three things. One is single point cutting tool, double point and multi point. Very important thing and very important questions. It may become your any interview also, any viva also. So in single point cutting tool, that means in at a time if tool and the workpiece touch, in touching zone is a point, 1 point or a one line. Okay. So this is called single point cutting tool. Example is turning tool, shaping, planing, slotting, etc. etc. Double or double point cutting tool, example one and only is drill. Because if you see drill bit properly, drill it one point touch the center and another point is the line or area when the circular, this is the circular area where the chip actually flows. So only drill is the double point cutting tool. And what is multi-point? That's when tool and the workpiece touch, so many point is touch. So milling cutter, broaching tool, hop, gear, shaping cutter, etc. This is the concept of single point cutting tool, double point cutting tool and multi-point cutting tool. Now, basic features of a single point cutting tool. The upper surface where actually the chip, unwanted material chip is flows easily. This is called rake face. And nearer to the which side is nearer, these two is auxiliary flank and this is clearance flank. Both are flank surface. Okay, one is auxiliary, one is principal. And this is principal cutting edge angle. And this is auxiliary cutting edge angle. And this corner, this corner is called nose radius. This is called auxiliary cutting edge. This is called principal cutting edge. And but this is principal flank, this is auxiliary flank, this is rake surface. This is the basic feature or basic diagram of a single point cutting tool. Question may come in your exam. Draw a single point cutting tool with proper nomenclature. What is rake surface? Which the surface of the cutting tool along which chip moves. Flank surface, the face of the workpiece. These are two flanks, namely principal and auxiliary flank. Cutting edge that remove material from the workpiece. There are two cutting edge. One is principal cutting edge and one is auxiliary cutting edge. And corner or cutting point, this is actually called corner radius. So in a front view, if you see in a lathe operation, you see that here rake face, this is a flank surface. Alpha is the clearance angle, gamma is the rake angle. This is the clearance and rake angle concept. Rake angle. Previously I discussed rake face. Now I will say the rake angle. Angle of inclination rake face from rake angle. Because if the rake surface is flat, the chip is not easily removed from the workpiece or rake face. So some angle is required, but how much? or this angle actually called rake angle, and clearance angle, angle of inclination clearance of flank surface and the finished surface. This, this and this. If clearance angle is not present, so many time jamming is created in the machining zone. After certain time, machining cannot happen. Okay, this is the importance of clearance angle and rake angle. With the help of this diagram, and rake angle is positive, negative and zero also. Positive rake, negative rake and zero rake. This is positive rake. If I draw a fourth angle, lowering that is positive, not, if you keep in your mind, this is negative rake and this is positive rake, this is zero rake. The diagram, you follow this very effectively, otherwise it may problem. What is the function of rake angle? It allows the chip to flow in convenient direction. It reduces the cutting force required to shear the metal and continuously help to increase the tool life, reduce the power consumption. It provides keenness of the cutting edge. It improves surface finish also. Now, what is the positive rake and what is the importance? Positive rake or increased rake angle reduce compression force and friction, yielding thinner, less deform and cooler chip. But increased rake angle reduce the strength also, tool section and heat consumption capacity. Some area of cutting where positive rake may prove more effective are when cutting tough alloying material that need to work hardening, such as certain stainless steel, cutting soft and gummy material. When low rigidity of workpiece tooling and machine tool or fixture allow chatter to occur. Negative rake, it provides greater strength. That's when very hard material, when or brittle, sometimes of brittle and hard material, when excessive amount force is required, negative rake this time is required. Okay, material tend to brittle, that their ability to hold their superior hardness to high temperature result in their selection of high speed and continuous machining operation. Negative rake increase the tool force, but it is necessary to provide added support to the cutting edge. This is particularly important in making intermittent cut and in absorbing the impact during the initial engagement of the tool and the workpiece. Negative rakes are recommended on tool which does not possess good toughness. Negative rake cause high compression tool force and friction, resulting in highly deformed hot chip. Zero rake, very simple design and manufactured in form tool. What is clearance angle? Very important thing. It is essentially provided to avoid rubbing of the tool with machine surface, which cause loss of energy and damage of both tool and the job surface. Hence, clearance angle is must be positive 3 to 15 degree. Very important thing. Less than 3 degree and above 15 degree, the clearance angle is not provided, because it before 3 degree machine cannot happen and jamming is created, and above 15 degree tool strength will be lower. Obviously, tool breakage is very more. Rake angle for a tool depends on the following factor: which material being cut, what is the tool material, what is the depth of cut, what is the rigidity. So a harder material like cast iron may be machined by smaller rake, then require more soft material like mild steel. Tool material like cemented carbide permits turning at high speed. At high speed, rake angle has little influence of cutting pressure. Depth of cut. In rapid turning, high depth of cut gives to remove the maximum amount of material. That means the tool has to withstand severe cutting pressure. So rake angle should be decreased to increase the lip angle. Rigidity, tool holder, and importantly, supported tool and old or worn out machine cannot take up high cutting pressure. So while machining under above condition, the tool use should have large rake angle. Cutting tool angle, they are significant. Side cutting edge angle. to increase tool life, to dimension chip thickness, the dissipated heat quickly, etc. End cutting edge angle. The function of end cutting angle is to prevent the trailing front cutting edge of the tool from rubbing against the wall. A large end cutting edge angle and suddenly weaken the tool. It varies from 8 to 15 degree. What is the important nose radius? Greater nose radius clear up feed marks caused by the previous shearing action provide better surface finish. All finish turning tool have greater nose radius than rough turning tool. To increase the strength of the cutting edge tends to minimize the wear taking place in sharp point of tool with consequent increase in tool life. Accumulation heat is less than it is that in a pointed tool which permits higher cutting speed. Tool point reference. Tool reference actually require in my upcoming slide I discuss so many tool signature is there in ASS system, ORS system or NRS system. I discuss my next slide. Okay, thank you. I think all of you understand the geometry of single point cutting